Good morning, everyone. I'd like to begin by saying that it's a great pleasure to be here today. My name is Kenji Omae. I'm a visiting researcher and a PhD candidate at Kyoto University. Basically, I'm a urologist, and my specialty is oncology. And I have a strong interest in evidence-based clinical decision-making. So today, I'm going to be talking about publication statuses of clinical trials supporting immune checkpoint inhibitors and other newest anti-cancer drugs recently approved by the FDA. First, I want to look at the background. What is known about this issue? Previous studies have found that a great number of trials supporting new drugs approved by the FDA remain unpublished, and that statistically significant results were more likely to be reported. The lack of timely and complete dissemination of clinical trial data can lead to unnecessary duplication of research and impair evidence-based clinical decision-making, thus violating ethical obligations. The low data publication rate for FDA-approved drugs and discrepancies between FDA-submitted versus published data remain a concern. Therefore, in this study, we investigated the publication statuses of trials of recently approved anti-cancer drugs documented by the FDA to determine the discrepancies between data submitted to the FDA and those published. Specifically, we explored the influence of drug type on the characteristics and the publication of their trials with a focus on immune checkpoint inhibitors. That the most recent and notable game-changing drug class in oncology with a completely novel pharmacological mechanism of action. I heartily congratulate these two doctors on their great success. Let's move on to the method section. This protocol for the meta-epidemiological investigation was registered. We identified all immune checkpoint inhibitors approved between 2011 and 2014. All other anti-cancer drugs approved between 2011 and 2014 were also identified, and 10 of them were randomly selected as comparison. For each drug, we assessed medical review documents and the FDA summary basis for approval to identify clinical trials submitted by the sponsor. We searched clinicaltrials.gov and ICTRP to obtain the following information for each trial: authors, industry affiliations, primary investigators' names, primary outcomes, and etc. And we also searched PubMed, Google Scholar, and the sponsors' websites to match each trial identified to publications in the literature between June and August 2018. The publication status for each trial was recorded as these 6 categories: full publication, full report, partial publication, conference abstract, none, and unclear. The primary endpoint was the rate of full publication within 2 years after the FDA approval. We also evaluated whether study identifiers, including NCT numbers or unique trial ID, were reported to determine the article discoverability. For example, once an NCT number was published as a part of an original journal article, automatically it is identified and indexed by the clinicaltrials.gov. We examined the multivariable association between drug type, study phase, and the time to publication using a multi-level Cox regression model, adjusting for the clustering within the drug indications and potential confounders. We further conducted a limited number of specified subgroup and sensitivity analyses. This flowchart shows the selection of new drugs and supporting trials. FDA approved 3 immune checkpoint inhibitors and 33 other anti-cancer drugs between 2011 and 2014. 10 drugs of the latter were randomly selected for this study. We identified 114 supporting trials for these 13 new drugs. After excluding 20 observational studies, 120 trials were ultimately eligible for this study. Table 1 summarizes the characteristics of included trials by anti-cancer drug type. ICPA trials are more likely to be a late phase and randomized and double-blinded study and included more participants. Nearly all trials reported adverse events, and the majority had authors affiliated with pharmaceutical industries. Over 20% of trials did not report all the predefined outcomes. This is a selective outcome reporting. Table 2 shows the characteristics of free published trials by presence or absence of study identifier in the published articles. In 20% of published trials, there were no study identifier was stated anywhere in the published article. All the articles from the phase 3 trials and those reported statistically significant outcome were described the study identifier. So NCT number and or unique trial ID in the published article. Notably, all trials from on ICPI drug, except one, described study identifier. On the other hand, there was no study identifier in the article in the 24% of other anti-cancer drug trials. This table shows publication statuses of included trials at 0, 2, and 3 years post-approval. Overall, 34% have not been published by 2 years post-approval. Among ICPA trials, over 40% was not remained unpublished. Figure 2a illustrates the cumulative proportion of fully published trials supporting approval of new anti-cancer drugs by study phase. Overall, the median time to full publication was 2.3 years. And there was no difference in the time to publication among study phases. Figure 2b also illustrates the cumulative proportion of fully published trials supporting approval of new anti-cancer drugs by drug type. We found no association of drug type with time to publication neither. Cox proportional hazard model analysis confirmed that drug type was not associated with time to publication. However, phase 2 or 3 trials were published significantly earlier than phase 1 trials after controlled for confounders. Figures 3a and 3b illustrate the cumulative proportion of full publication of all and randomized only phase 2 and 3 trials supporting approval of new anti-cancer drugs by drug type. When limited to randomized phase 2 and 3 trials, other anti-cancer trials were published significantly faster than ICPA trials. Sensitivity analysis using multivariate ordered logistic regression analysis confirmed that drug type was not associated with ordered publication status at any time point, 0, 2, and 3 years. However, study phase was associated with time to full publication at 2 and 3 years. As for subgroup analyses, although we found no association of drug type with time to full publication, limited to randomized phase 2 and 3 trials, drug type was significantly associated with time to full publication. Here, I'd like to summarize the main findings of this study. The median time from FDA approval to full publication of 120 supporting trials for 13 new anti-cancer drugs was 2.3 years. And 1 in 3 trials remained unpublished by 2 years post-approval. We found no association between drug type and time to publication when considering all trials. And publishing randomized phase 2 and 3 trials took longer time compared with times for ICPIs compared with for other anti-cancer drugs. We found the publication rate of the most recent anti-cancer drugs was higher than those found in previous studies. The statistical significance of the results was not associated with earlier trials. These findings suggest an improvement in the dissemination of clinical trial results. And however, the overall publication rate of 66% remains insufficient to satisfy the responsibilities of medical and academic enterprises. Actually, at least for me as a clinical physician, the number is surprising because I guess most of clinicians or patients and policymakers believe that almost 100% was fully published. I'd like to emphasize that, stakeholders, including researchers and sponsors, as well as journals, ethical committees, and governments, ought to invest additional effort to promote the timely and complete dissemination of findings in clinical trials. To the best of our knowledge, ours is the first study to evaluate the reporting of study identifiers in published clinical trials. Such identifiers were less frequently included in articles on earlier phase trials. This suggests that searching for systematic trials using study identifiers is unreliable and could result in undercounting publications and incomplete data dissemination. Therefore, authors and sponsors are encouraged to include study identifiers in every article, regardless of the study phase or statistical significance of the results. Our study has some limitations. First, ours are limited to trials for anti-cancer drugs, so our results are not generalizable to other clinical areas. Second, because we focus on the newest anti-cancer drugs, limited time follow-up times were limited. So longer follow-up will yield more additional publications, although they are not qualified as timely. Third, although our search was thorough, it remains possible that we missed some published studies. Lastly, as is the case with all observational studies, causal inference cannot be made, and additional unmeasured variables may explain the differences in time to publication that we observed. In conclusion, incomplete transparency and a delay in dissemination of clinical trials supporting FDA drug approval was still prevalent. Further efforts and continuous monitoring are necessary to enhance timely and full publication of clinical trial results. I'd like to thank all the members in our research team, who you can see here, for all their hard work. Without all the support from them, I could not have done this research. Actually, the most tough part of this study was searching and data extraction. In this study, 4 investigators, including me, worked on that independently, and disagreement was resolved by discussion. Well, that wraps up my presentation. Thank you for your time and your attention. It's been a pleasure. If you have any questions, I'd be pleased to answer them. Thank you.